All right, 9.2 graphs of polar equations is exciting. Some of these graphs will come up pretty neat. Some of them are pretty standard. These first couple will fall into the pretty standard category. Let's get started. So if we do just a couple basic values. I did not want to do that. We want to draw. So theta, and we want, in this case, we're doing r equals negative sign. Let's start with 0. You put 0 in this, what do you get? You get 0. Let's try pi over 6. Pi over 6, you put that in, you're going to get negative 0.5. I'm going to keep doing this for each pi over 6. Pi over 3 is going to be approximately negative 0.9. Pi over 2 will be negative 1. And I finished up to pi, and then if I go beyond some pi over 6, it's going to follow the same pattern, except it's going to be positive values, right? So let's graph. So we got 0, 0. Plot that point. I'm going to make my life easier, I'm going to make the outsides 1. I know it's going to be kind of goofy. So like when I say that is r equal to 1. Okay. So we'll approximate from there. So 0, I'm going to pi over 6, comma, negative 0.5, which will get us about right here. And then negative 0.9 pi over 3 there. Pi over 2, negative 1. Pi over 3, negative 0.9. Negative 0.5. Comma, can't read that. 5 pi over 3, there we go. 5 pi over 3, negative 0.5. And then pi, comma 0. And then if I had 7 pi over 6, I would get 0.5. So it'll just be keep going in this, getting the same values over and over again. Now, if you wanted to do a different scale than this, go for it, because we're going to get times whenever r will be beyond 1. As in this next one right here. I'll make a chart for us. Here's a chart for your 2 cosine theta graph. Let's start plotting the points. If we continue on from here, it'll continue to be following the same pattern. 0, 2. So we'll make the outside. I'm going to make the outside 2 this time. Okay, r equal to 2. Once again, helps my drawing on this device here. So we've got 0, 2. And then pi over 6, 1.8. Pi over 3, 1. Right there. Pi over 2, 0. 2 pi over 3, negative 1. 5 pi over 6, negative 1.8. Then pi, negative 2, which can be down here. So once again, connect. Kind of circly, but not exactly a circle. Cool. There's 3 different types of symmetry. Here are first 2. Symmetry with respect to the line, theta equal to pi over 2. Kind of looks like this in the graph. And if we were to put negative r and negative theta into the equation and we simplified it, it'd come out to be the same thing. with respect to the polar axis, graph may look something like this. If we put negative theta in and we simplified, it will come out to be the same thing. And then finally, symmetry with respect to the pole. If we put negative r in and simplify it, it will come out to be the same thing. You'll see this more, something I'll show you towards the end of the video. We're going to do an example right now. I'm going to make a minor change to 1 minus cosine theta because I just realized your book gave you an explanation for 1 minus 2 cosine theta. Now this graph is going to come out to be what's called a limacon. And there's many different types of limacons. One in your book for on page 543, if you look at the one on 543, it's going to look a little bit different than what you're going to see for this graph right here. Also, if you remember your rules from chapter 5, I would have said that cosine of negative theta is just equal to cosine theta, right? Remember that? Yeah. That should help guide you with what symmetry you have for this one. And the symmetry you have for this one is respect to the polar axis, because if we put negative theta in, we're going to get the same value coming back out. Okay, I'm going to get rid of this for space. That's going to help guide us in graphing this. So if I put 0 into this function, they'll get us cosine 0 is 1, 1 minus 1 is 0. So 0, 0 is a point. That's not going to help us with really symmetry right there. Let's do another one. Let's do pi over 6. A cosine of pi over 6. That will get us approximately cosine of pi over 6 is 2. That's going to get us about 0.1, give or take, right? So we'll do that. We'll call that 0.1. If I were to do pi over 4, pi over 4, that will get us about 0.6, about 0.3. So we're moving over a little bit and getting a little higher. And now if I go to pi over 3, that will get me pi over 3, 0.5. So getting up a little bit. Then pi over 2 will get me 1. Because 1 minus 0 is 1. Let's go over here. Let's do 2 pi over 3. 2 pi over 3, that will get me something large here. That will get me 3 halves. So a little bigger. And one thing I want to point out is, since it's symmetric with the polar axis, if I go over here, it's going to be the same values when they're flipped, which is going to help us out in saving time graphing these. I keep going, and at 5 pi over 6, that would be, so cosine of 5 pi over 6 is negative root 3 over 2, which is going to be pretty close to 2. And then pi, of course, will be straight up 2. Call that 2, pretty close to 2. Ooh, that's ugly. Let's fix that. Bummer. Let's do this. I missed that one, but it's okay. So there's a little point at the end. And if you were to see the example in your book, there's a little loop right around here for that example. You'll see later in this video what determines what type of limacon it is, depending on what is happening in this equation. That will help guide you a little bit. Now we get to draw pretty flowers. Oh, this is the best part. I love this. This is fun. So, little tip for drawing your pretty flowers. If you have an odd number like you do with this one. This is how many petals you will have. You will have 5 petals with this one. If it's an even number, it is not going to be 2 petals. It's going to be 4. You double it. Okay. So if it's even, double that number. If it's odd, keep it the same. So you should expect 4 petals here, 4 petals, and over here you're going to have 5 petals. And symmetry is going to help us. That's why it says use symmetry, or else we're going to be doing this all day. We don't want to do that. That's not fun. No fun. Even though it is math, we are having fun. We're drawing flowers, but we don't want to spend more time than what we need to. Now, which way are they symmetric? If I were to put negative theta and negative r in, it would come out to be the same thing. Because sine of negative theta will be negative sine theta, so that right side becomes negative, and left side is negative. So it's going to become positive because you divide both sides by negative. So it's symmetric over pi over 2. This one over here, since it's a cosine function, it's going to be symmetric over the polar axis. That's going to help us. So if it's sine 2 theta, I'm going to start with that. So I'm going to label this to make our life a little easier. I'm going to go ahead and, I wish it was a little bigger here, but it's okay. We'll call this 4. Okay, we'll bring it all the way up to 4. If I put 0 in, your output's going to be 0, so boom, 0. If I put, it's going to be ugly. I don't want to do, I'll do pi over 4 to start. So 2 times pi over 4 is pi over 2. Sine of pi over 2 is 1. 1 times 3 is 3. So pi over 4 is somewhere in the middle here. So it's going to be 3 right there. If I were to do pi over 6, that will get me 3 root 3 over 2, which will be a little less, so somewhere around here. And if I were to do pi over 3, that will get me sine of 2 pi over 3, which is root 3 over 2. Same story, 3 root 3 over 2, so same thing on the other side. And it will just go back down. But if I put pi over 2 in, sine of pi is 0, so it would come back to 0. So it would give me a little something like this. All right, cool. Now, where are we symmetric over? Pi over 2. So if I have one right here, I'm going to have one flipped the same spot. There's 2 petals right there. Now I'll keep going round and round. It's going to be the same story down here. So if I put 5 pi over 4 in, that'll also get me 3. It's going to be the same story if I were to plug in the other values, right? And then, once again, remember it flux over pi over 2, so we're going to have 1 over here as well. Made that one really large. My bad. Now we have 5 petals. Cosine of 5 pi over nothing. So the first one's easy. We put 0 in. Cosine of 0, you're going to be 1. So right there, petal. Now where does it end? Remember, cosine of pi over 2 and 3 pi over 2 are when it's 0, right? So when will this function, when will the 5 pi, or excuse me, 5 theta be equal to pi over 2? That would be at pi over 10, right? So it's going to be very quick. It's going to be a very quick whoop and whoop. I made that a little bigger than actually what it is. It's hard to do, but it's going to be really quick. Boom, 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 right there. When will it be equal to? When will cosine be 1 again? When it's going to be equal to pi. So at 5 pi over or excuse me, pi over 2. Yeah, let me try that again. At pi over 5, you will get another, this one would be -1 actually. So 5 pi over, pi over 5, which will be is like right there, right? That's going to be when it's going to be -1, right? So it's going to be over here. Actually, pi over 5 is a little bit above pi over 6. My bad. So it should be right around there. And it's going to be pretty quick again too, right? Because if I make pi theta equal to 3 pi over 2, next time it will be 0 again. 3 pi over 10 will be when it's 0 again, right? So that's approximately what? A little under here, right? So another quick boom, boom. Now, how do we know it's symmetric over the polar axis, right? So we have one right there. We know we also have one that's a little above here as well. Now we have to do one more. How about when will cosine 5 theta once again be 1? So 5 theta equal to, we did 0, we did pi. How about 2 pi? So 2 pi over 5. Where's 2 pi over 5 at? Somewhere over here, right? And that's going to be a next one. So it's going to be a quick boom, boom again. And then down over here, it's symmetric over that. So it's going to be right, boom, boom, right there. So now you're having 5 petals. Hopefully you drew it a little nicer than I did. Now if you go to 546, you'll get a chart that says all of your lovely little different types of graphs you might have with your polar graphs. We're going to do one more of these together. And R squared ones are easy because you know what is going to happen and what type of symmetry, generally speaking. So what type of symmetry do we have here? We are going to have, well, which one do you think it is? How about that? Which one do you think? Tick, 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 tick. If you said theta equals pi over 2, you're right. If you said polar axis, you're also right. And if you said the pole, you're also correct. All three of them. They're symmetric over all three things. How exciting is that? So, let's begin. So, put 0 in. It's going to get me cosine 0 is 1. So r will be equal to plus or minus 3. So we'll call this 3 right here. 3, and also 3 on the other side. Now I put in pi over 4. That'll get us 0. Because cosine pi over 2 is 0. Automatically making it 0. So how about in between? Pi over 6. That'll get us 9 over 2, right? Yeah. Square root of 9 over 2, plus or minus, right? So if I go up here, you get us root 3 over root 2. So yeah, it's going to be up here. So it's symmetric, so it's going to be, I'm going to make one right there as well. Did it horribly, so near. And then same story over here. Near. And I would add a dot right here as well. Cool. Appreciate you watching. Check out the chart, please, and have a lovely day.